So let's get started. Let's talk about security. And first, I'd like to introduce you to the world's most secure computer, the only computer that is totally secure. And this is something that you will bring all of your applications, aspire to be as secure as this computer. So it's of course the beat computer. It's not connected to anything. There's no user inputs. There's no network to protect. And really, if there is a leak, the only thing that will happen is that you will step on some of the beads and maybe hurt yourself. But really, that's pretty much it. So this is essentially the kind of ideal case. This is the most secure one, also the least useful one. So there's also all sorts of balance that we need to find. We need to essentially make up some compromises. And those compromises related to security can be thought also from the point of view of this classic triangle. Essentially, you may pick any two of these if you want something that is good and fast. It's definitely not cheap. If you want something that is cheap and fast, it's definitely not good, and so forth. And actually, in this security space, we have our own interpretation of this similar triangle. And because in the security space, we work a lot with cybercrime and organized crime, and also preventing organized crime, they actually call that the CIA security triad. That's the actual name. It doesn't stand for any intelligence agency, and it doesn't have to do with triads as in the is it Chinese mafia, essentially. But it is about confidentiality, integrity, and availability. And these are essentially security properties. These are the things that we want to perform. You can also think of this, if you're a pessimistic person like me, you can actually think of these as reverse. So if you think of information disclosure, that's kind of the reverse of the confidentiality property. If you think of a malicious person modifying your data, that's a threat vector, that's an attack against the integrity of your application. If you think of availability, of course, the attack that is kind of attacking the availability property will be, for example, a denial of service attack. And typically, we need to prioritize in our application some of these, or hopefully at least two of these parts of the CIA triad. Most likely, we don't have the resources to focus on all of those. And this is the mindset, this is the set of tooling that you will need to think of when you are thinking of which sort of security controls will be actually put in place. Is it something that we'll just throw money at the problem? We'll buy a more expensive security license from Azure? Or is it something that we need to maybe even drastically change our architecture? And in the end, of course, if you are building custom apps, that will mean more work hours doing something that are not related to building new features. Those will be these kind of non-functional requirements, and very often, like design, testing, and so forth, security is also something that gets left out in the end in lieu of features as well. So having this CIA triad in mind, let's start talking about those security controls that help us provide these security properties, this confidentiality, integrity, and availability. And first up, the one that we usually know very well is the authentication and authorization. That is definitely help when we know who the user is. That is definitely helping us to actually make sure that the data stays confidential. We only give out the information to those users who need to know that. And if necessary, if you think of something very strict security like finance or maybe defense related, we might even want to give out different levels of details to some people. You might not have access to all of the company's sales data. You might only need access to maybe just your country's or your territory's sales data, and so forth. We need to be very strict, specifically on the cloud, because if this fails, then this is much bigger attack threat than previously, because essentially we are exposed to the public through the internet, essentially. Encryption, or most of us know about encrypting data at rest, meaning that when the actual storage is actually encrypted, also data in transit, so we actually connect to our data solution securely. This is of course about the confidentiality of the data as well. A ton of monitoring. We actually don't need to put in a certificate or an encryption or some sort of strict authorization in place. Sometimes just monitoring what's going to happen is also good enough for us, depending on what part of the triangle and depending on the severity of the project that we are dealing with as well. So just knowing that something is happening might also be a good control. Then there's something that we are very familiar with. There's backup, disaster recovery, building resilient architecture. This is, of course, related to the availability of our application. And before this platform as a service world, we actually needed to think about this host hardening as well. So this really meant essentially patching our virtual machines. This meant maybe configuring them properly when there's a zero day happening. We needed to essentially subscribe to a feed of new security incidents and just essentially react to those very fast. Now with the platform as a service world, in a lot of the cases, we actually make Microsoft or make the host or the cloud operator actually perform these hardening capabilities for us. But it is still our responsibility if you are dealing with containers or virtual machines. Here's an example of the things that we will need to do. This is essentially from Azure Security Center. You can actually have this list of security best practices related to hardening your virtual machines. And you'll see that there's over 100 different, actually 100 different failed rules actually in this case. This is a data set from the security center analyzing one Windows virtual machine that is just, created from the Azure Marketplace. I just select the latest version, click, next, and so forth. Everything is still our responsibility, even though Microsoft patches the image for us. If I create one now, it has the latest updates, but I'm responsible of updating and configuring it on my own if I choose to go with virtual machines. Regardless of what services we are using in Azure, is it virtual machines or something else, we have a lot of security controls available for us. And some of these services are, like, for example, the privacy and compliance. Some of these services are really something that we just need to learn from the Microsoft documentation, or maybe even our agreements with Microsoft, that how is Microsoft handling, for example, encryption of their data? How is Microsoft actually handling the destruction of hard drives, for example? Microsoft has detailed in obvious certification-related reasons. Microsoft has actually described how they are performing this data destruction, for example. So if you go and look up the service trust center from Microsoft, you'll actually learn that no customer hard drives actually leave the data centers. They are actually crushed to this small powder actually on the premises, so at the data center. And before that, they are actually being essentially sanitized and formatted several times, so that we will be very much sure that the data is not getting accessed by somebody who should not. But some of these services and some of these controls that we have are actually available as features or services in Azure that we need to turn on, or we just need to understand them a little bit better. The main topics that usually come up are really the authentication and authorization related to Azure AD, role-based access control, understanding the visibility between different scopes, resource groups, resources, And also, if you have role-based access control in place for a specific set of Azure services, there are things that we can actually use to override them. We can have Azure policies actually in place to kind of make sure that from the point of view of the Azure service, even though you have owner privileges, for example, you still wouldn't be able to perform certain operations. And same with the logs. Logs are actually something that prevent you from, for example, deleting a service, which is obviously about the availability, or preventing you making any modifications, so granting you a read-only access as well. And there's a ton of stuff available, and we can analyze all of these using our applications and business kind of confidentiality, integrity, and availability requirements. But in the end, even though these tools should seem quite basic and seem something that are very easily implemented, this is really the reality. So this is actually from a set of scans that I've ran towards an actual customer subscription. It's a small enterprise customer. They don't actually have a lot of stuff on Azure. So if I'm just going to highlight a couple of things over here, so that you'll see, there are roughly 200 different Azure resources available in this set of subscriptions. And we'll see that they're using basic Azure services like storage, Azure App Service, SQL database, and even some virtual machines there as well. And actually, you'll see a lot of failures in here as well. Even though this is an enterprise customer, they have strict processes on how should you create a new app service, how should you configure your virtual machines. There's still a lot of room for improvement. And how do I get this sort of data? So getting this data is something that I could go and manually analyze all of those resources, log in as the enterprise IT administrator and just see all of those Azure configurations. Or I could start to use something called Secure DevOps Kit for Azure that actually was used to create that scan that you just showed. It wasn't a custom portal or anything. It was actually a built-in dashboard that was provided to me by this AzSK. And AzSK really is a set of tools for analyzing and assessing the security posture or security of our Azure environments. So it doesn't go inside my application. It doesn't analyze kind of a web application level vulnerabilities, but you can definitely analyze these Azure resource level or Azure management level configurations. It doesn't replace the Security Center. It actually uses Security Center for those virtual machine or those infrastructure as a service capabilities. And you can actually use this AzSK to configure your Security Center as well. You can create alerts, set policies, and so forth. It's actually built by Microsoft IT. That they call themselves Core Services Engineering now. So this is not built by any Azure security product group or anything like that. Actually, this is the tool that Microsoft uses to evaluate and assess the security of their own Azure applications. So since last Ignite, they actually are publicly telling us that they have over 1,000 subscriptions that they are actively scanning or securing with this AzSK. And it's actually quite easy to get started, and I'm going to show how do you get started with using AzSK quite soon as well. But it actually is a set of features that evolves actually all the way up to these kind of continuous assurance dashboards and automated scans, and you can even have plugins for your different products like Jenkins or maybe even Azure DevOps and so forth. And really, some of the features that we have for AzSK start with really the scan. And I've been calling in some cases these security scans as unit tests of your Azure environment security. That's one way of looking at it as well. We have two types of scans. We have the subscription health scan, which is mostly about authentication and authorization, but there are also a couple of other things that are added there. But the main feature, the one that's a little bit more detailed, is the SVT scan, and SVT stands really for Security Verification Test. And that one actually goes deeper into different specific Azure services, like have you configured your app service properly, have you configured your virtual machine properly, and so forth and so forth. There's actually even if you're still using this full-blown real Visual Studio, the full IDE, there's actually a security intelligence plugin for that. You can just search for secure intelligence in the plugin library. It's free to download. It gives you the red squiggly lines on top of your actual work environment. Not available for Visual Studio Code at the moment. There's a ARM template checker, so you can actually use this AzSK ARM template checker to verify the security of your ARM templates before you actually start deploying them. Or you can just deploy them and run the regular subscription and security verification scans in the end, but that does take a little bit more time. There's a plugin for Azure DevOps. There's a couple of other services available there as well. But really, if we start talking about this main feature, the scanning part, it is very simple. I just run a line of PowerShell. No Azure CLI at the moment, so you do need to be a Windows administrator, so to say, to run this. I just run that one line. I get a ton of Excel files and log files as an output. I will do the actual work of analyzing those results. I get recommendations, I get statuses, did this fail, is this something that you need to manually check, and so forth. And hopefully in the end, you will actually take those results back and actually make some changes and run that scan later and hopefully get better results at that time as well. And let's have a look at those subscription and security verification scans. I have a couple of examples on both of them. And the first one on the subscription health scan is really about this access control, authentication and authorization. And there are a ton of different controls or security checks that they perform related to are you having external accounts in your Active Directory, are you using too many owners, etc. There's a set of tools and set of checks related to governance, really this kind of train your users type of mode. So it actually, if you have some unresolved security center alerts in there, it actually tells you to fix those, and that is one of those scan results or one of your security pass or fail arguments in there as well. You'll get the slide later. I won't be reading through all of those line by line, but there are also some scans related to those classic resources. We didn't have proper role-based access control with the Azure ASM model, the predecessor to ARM, which means that anytime you have an Azure classic resource in there, that's of course some level of a threat, so we do need to scan those as well. So this was the subscription health scan. This is pretty generic. It doesn't actually tell you anything about your configuration of your Azure service yet. Boom. This is then the security verification test, SVT scan. Essentially, these are all of the services that you get actually recommendations related to the security of your environment. So if you have any of those services in use, you can use AzSK to actually get best practices, security recommendations, and also an analysis of how are you currently doing against those recommendations. Sometimes just the fact that you had on your backlog, or your colleague claims, or you think that you actually configured something properly. Sometimes that actually doesn't mean that that is the case. So this is a good way of verifying the security, right? SVT. Also, if you think about it like this, this is the tool that Microsoft IT uses to analyze the security of their applications, right? So essentially, this is the list of services that Microsoft actually uses on their own line of business applications that are supported by Microsoft IT. And this list is, of course, evolving. Some of the latest additions that we've had are the Azure Kubernetes service, Databricks, and so forth. And there are a ton of different scans. Some of those services have much more recommendations than others. But let's just have a look at one of those services, and that will be the Key Vault. So if you have a Azure Key Vault actually provisioned in your environment, and if you run this SVT check against that environment, you will actually get, for example, these checks, these as a result of your scan. So there is this kind of manual best practice actually telling you that because there is no proper access control for Key Vault for the scope of the users, you actually should not share a Key Vault with the different applications if those applications are not in the same trust boundary. So if you have, for example, production environment and development environment in your subscription, you should have a separate Key Vault for them for these access control reasons. It will also tell you that you should actually enable the Key Vault diagnostic logs, which definitely makes sense. If you have secrets that you want to store in a secure way, most likely you want to have that monitoring security control in place for those Key Vaults usage as well. So the middle one is not this sort of manual test or recommendation of a best practice. The middle one is actually something that you do get a technical kind of pass or fail. If this is configured properly and there is at least a year worth of diagnostic log retention, then you will get a pass. If not, you will get a fail. Very clear and actionable. And the last one, secret rotation, key rotation, that is again something that has to do with your process. The actual scan does not really go into too much details. If you have some sort of expiration dates there, you can kind of fool your scan and you can get a green check mark, but you should also actually implement this as part of your actual key management process. So let's see how we will install AzSK. Very simple. It's one line, install-module AzSK. And most likely, if you like me have several Azure PowerShells and several versions of different tools in there, there's some sort of clubber in there. So I just typically just tell my customers to just directly use the force and allow clubber in there so that it actually forces the installation to go properly. And obviously, it does require the Azure PowerShell modules to be installed as well. Nowadays, it does support the new AZ type of Azure PowerShell, but there's no AZ CLI, so there's no Mac or Linux support for those yet. You can install this in your Azure Cloud Shell, for example, and you can use that if you don't regularly use PowerShell on your environment. So I made things very simple for me. I won't be typing. I will be showing you very well recorded parts of my demo. There are videos available that I will point later where I will perform these live as well, but really I'm not that much of a stand-up comedian to actually make all of you wait 5 minutes for the scans to actually run. So let's have a look at how do we actually work with that. So the subscription health scan is very simple. Once we have the tool installed, it's get AzSK Subscription security status. And then as a parameter, it takes in the subscription ID. You can run this against a specific resource, specific directory or specific Azure AD tenant, and you can have different subscriptions that you will scan with a different lifecycle maybe. Then the next one will be the security verification test. Very simple. Again, AzSK Azure Services security status, not Azure security status, and then passing in the subscription ID. And if you want to just scan a smaller amount of resources, you can also specify the type of resource that you want to scan or the resource group that you want to scan. This takes a lot of time, depends on how many services do you have. It will take a couple of maybe 30 seconds per service. So if you have 100 resources in your Azure environment, it means that it will take a lot of time to run. So that's why it's usually quite good to specify a little bit smaller scope for the security verification test. And once you run this, you will actually get a nice set of Excel files. So I will first start with the subscription health scan. So essentially it's just a CSV file, as you'll see. Just very quickly to walk through what do we have here. I have a list of security controls. These are the names of the checks or scans. I have a status, whether it was failed or whether it passed. As you'll see, we have, for some reason, two different categories for manual checks. So we have manual and we have verify. So they are just Microsoft's internal process-related names. And then we, of course, have the severity that they define. I don't think there are low severity ones over here. So everything is either high or medium. And apparently there's even a critical version that we have available as well. So the name of the control, whether it passed or failed, then a severity, and then a description. Do not grant permissions to external accounts. How do you check that? In some cases, you have a nice PowerShell command that they will give you as a recommendation. So you'll see run command, remove Azure RM roles, etc., etc. This is very much actionable. In some cases, the recommendation how to fix this is, for example, like this. There are 2 steps involved. There's like links to documentation or steps that you need to take in the portal. This is not something that I can automatically fix using a line of PowerShell. So as a security consultant, I come in, I essentially just take a look at all of those that are failed, like this, and then this is the work for me for the next several weeks. And essentially, you'll see in this case, I actually have been using these external identities. This is a Microsoft internal best practice, so this is not a generic best practice against not using guest accounts, but Microsoft inside Microsoft, for Microsoft IT's own services and applications, they actually require all of those users to be coming from the Microsoft Azure AD. So fair enough, let's have a look at this. So actually, if you scroll a little bit further, we'll actually see that there is a link to a detailed log file as well. So there is actually a subscription core.log file that actually has more information, and we can have a look and try to find out who are those external accounts that we have here. And this is a view of that log. You'll see that this is very big one. This is only like this. So this is the part that we are seeing now. This is why it's nice to have this Excel sheet that kind of gives us the overview. But if you find something that we want to dig deeper, how do we fix this? We can try to find this specific security control. In this case, that control was this: don't use non-Azure AD identities. We have some timestamps and everything, and finally we'll see that there are actually 2 role-based access control assignments to some users that are not in our own environment. So we'll see that this Carl that is added here as a reader for the subscription and a specific portal dashboard is actually not coming from our own. In this case, this carlodds.onmicrosoft.com is the home directory of this subscription. So we'll see that this carl.odds@azure.com is actually an external account, a guest account that is just linked to my directory. So now this is good. I can kick Carl out and everything's good. If I run the scan again, I will get a pass for that. So that was the subscription health scan. The other one, which was the more investigative or more detailed one, is this security verification test scan. And in this case, I have actually more than 1 categories in here. Previously, I only had 1 category called subscription. Now I actually have, based on the amount of services deployed into my resource group, I actually have that many categories. If your service that you are using on Azure is not supported by AzSK, it just gets omitted here. So you do need to double check whether or not you are actually scanning for all of those services on Azure. So I can have a look at all of the app service controls. We'll see the specific Azure resource name. We'll see again the status failed, passed, manual, and we also see the severity from the Microsoft point of view. And again, we have a description, we have a recommendation. In this case, it's a step in the portal. And again, we have a link, specific link to that subscription, that resource, and a specific link to more detailed log file for each of these services again. So for a generic subscription, you'll actually see that we had something like 20 different controls available. Yeah, 20 controls for the subscription health scan. Excuse me. For the security verification tests, if you look at an app service, only for app service type of resource, we have 28 controls available. So if you have 2 app services, you will actually see this number doubled in your security scans. And in my case, I only had an app service and a storage that I scanned. Altogether, they are, altogether, apparently the hiding didn't hide the numbers over here. So altogether, we have 29 different controls from those storage and app services that we can go into more detail and see what can we do with them. And once we have those security scans analyzed, this is of course something manual, so we need to manually go through that Excel. We can even just dump all of that information on that CSV file and generate a PDF if we want to give someone a nice long report of our environment security. Or we can actually automate this, because this is just PowerShell, so we can actually automatically store, instead of a CSV file, we can store this information in, for example, Log Analytics or App Insights. And here is an example of that data in Log Analytics. You'll actually see that this is just a new field called AzSK Custom Log that I'm querying. I have all of the same set of information, so everything that we had on that Excel sheet, I now have here. So there's whether it passed, whether it failed, whether it's a manual test. Then we have the name of the control, the resource, and so forth. The dashboard with nice colors and those donuts that I showed you in the beginning is actually based on this sort of data. So whether I run this maybe every release or just maybe every day or every week, I will get this. If I put all of this in same log analytics, I will actually get a nice overview of how well am I doing over time related to my security, not just this kind of spot checking of our security on that given time. Okay, and you can actually integrate this with Azure DevOps as well. So there are actually both for these SVTs and subscription health scans, there are actually plugins available. But again, you don't really need to have a pre-made task for you, because this is just one line of PowerShell. So it's pretty simple to automate on your own as well. But essentially, in this case, I'm actually in my Azure DevOps release, I actually have as one of those steps, as you'll see, I have an Azure App Service deployment, and then I have, as a next step, I have an AzSK security verification test. And in this case, I've actually failed. So you'll see we had 5 errors, and I've configured my deployment in a way that this actually fails the whole deployment of that release. So we'll see again, these are the same controls. This is related to storage. We have the name of the storage, essentially the same set of tasks or same set of security controls that we had in our manual run or in the Excel, or something that we could put into the log analytics, now available as a technical blocker or technical step in our Azure DevOps release. There's also, I could actually, before running this against this live environment, I could also integrate those Azure Resource Manager template checkers in here as well. Okay. Then a brief overview of some of those tests that I typically see failing. For the longer list and more rant, see my session from yesterday. Essentially, a big chunk of those things that I see failing very often are related to this authentication and authorization. So typically, it's about having too much privileges in too wide of a scope for users or for automation accounts or service principals. Or it could be failures related to not using SAS tokens, not generating this storage access keys dynamically. Then another big category is really about monitoring and alerting. Specifically, the Key Vault. Key Vault's audit logs are for some reason hidden underneath this name of a diagnostic log. It's not really about diagnosing or troubleshooting. It's the core feature of the Key Vault that we should take in, and we should have a look at those retention times in great detail. Oftentimes, Security Center has alerts that we don't care or we haven't fixed, but we haven't snoozed those alerts. Very often there's no web application firewall in place. All of those just tick in the box or pay a certain version on Azure, like App Insights, Azure SQL, Storage ATP. All of those kind of very powerful, very easy to get put in use alerting tools are missing very often. And then the storage account security in more detail. Essentially, we have 2 ways of securing storage accounts or securing the access to storage account, not just the network or monitoring point of view, but the authentication and authorization. So the first one is that there is no authentication. There is anyone who gets their hands on the master key of the storage account is automatically authorized to do anything on that storage account, meaning that actually if I have that key, I can create and read, delete anything that is actually stored on that storage account, and there's no way of knowing who is actually using that key, which application is using that key. It's only one key that we share with all of those storage accounts, with all of the applications and users of that one storage account. The other one is actually about authenticating through Azure AD. And if you authenticate through Azure AD, we actually get the benefit of this role-based access control. If our application is new enough, we can actually turn on the managed identity for that resource, the client that's actually requesting access from storage. Or if we are authenticating using a service principal, we store some certificates or keys on our application and grant access to that service principal to have pull data from Azure storage. It seems my version control is off. I accidentally deleted my slide about role-based access control, so I'll just paint you a picture about a storage role-based access control. So essentially there is pre-built-in roles nowadays available that don't just give you access to that key, but give you access in the data pane, in the data level of that storage account. We used to have role-based access control roles for storage, but the previous storage roles were actually related to who is actually able to get that key, who is able to list the keys, the master keys that will end up in a disaster if we list those keys. The new roles, the current role-based access control roles for storage are related to who is actually able to see the data without having the need to get the access to the keys. So we can even put in place, for example, an Azure policy saying that nobody is able to perform that list keys action on Azure Resource Manager level. So nobody sees the keys, and everybody has to be authenticated or authorized using Azure AD to get that access. Those new roles are actually just in general availability. So any new usage that you will any new services that you will build, you should definitely take those into use, not just those shared keys on Azure storage. Okay, so how should you take this AzSK into use, and how should you start thinking of securing your applications on Azure? Well, obviously, start with these scans, start with the subscription health scan, start with the security verification test scan, and see what's there. You might think that you have worse or better security. Let's get some data in place and let's see what is going to happen. So it's a single line of PowerShell. You only need a reader level of access, and most likely you will be busy for a while after you run that first scan. After that, try to educate your people about the utilization. You can add this as in a very restricted version, as I had on my release pipeline. So if your scan fails, then you can't deploy anywhere. So that's a very restrictive way of putting this in place. Or you can just share this tool or share as a best practice that, hey, people in the other team, have a look at your environment with this subscription and scan that. Or you could even have an internal kind of central team that runs those scans against the whole of your organization, and maybe even publicly shames the people who get more fails than others. You know, you can always gamify that and put those dashboards in place as well. It really is about awareness and educating the teams about those tasks. Some of those security tests are actually not always useful for us. So after we've done dealing with the defaults from Microsoft, we can actually start customizing those. And for example, if we are totally fine having those external Azure AD identities in there, we can actually remove the control altogether, or we can configure it in a way that it maybe checks more deeper that which sort of roles, which sort of external companies are we inviting people in, or something else. We can customize this to our own organization's needs as well. There's a ton of new features coming. There is roughly a 5-week release cadence from the team. They are updating this all the time. The biggest kind of slower or blocker in the past maybe 6 months was really the release of the AZ type of PowerShell. They actually went back and forth and even had a faulty release for a while where you didn't actually, neither of the versions worked. And now they're back again, and we can use the new current AZ level of Azure PowerShell, which is good. So now we get to see some of the new security features here as well. We have a scan in preview for Azure AD, not just your Azure resources, but how is your Azure AD configured. Same for the VSTS or Azure DevOps. There's actually, if you are using this privileged identity management, which does require an additional license, Azure AD Premium P2. Then if you use that PIM, you actually realize quite fast that it actually is a lot of pain to actually automate those role changes with PIM. We used to have only the UI available, the SDKs weren't there yet. A lot of the support was actually made for the Azure AD version of PIM, not just Azure version of PIM. So now AzSK actually provides tooling for removing all of those role-based access controls in the static assignments or permanent assignments and recreating those assignments in PIM world as well. So there's a lot of helper modules and tools available with AzSK. And we actually go even deeper inside some of those services. So we actually can go inside an AKS cluster or HD inside Spark or Azure Databricks and actually have those nodes, have those cluster components reporting back to us as we go. We can set up these automatic scans in our AKS and have them report alongside the regular SVT scans into our Azure Log Analytics as well. And really, AzSK is just one of those tools. It's really not supposed to be there to just help you tick the security box. It's a very good amount of information related to Azure security best practices in general. Typically, if you would want to learn about Azure securing different Azure services and you would want to get all of those security parts in one view, you will need to go and actually essentially learn through all of the documentation of each individual service. Now you get all of them in nice one place. And also, if you are thinking of what is enterprise security looking like, this is essentially the list of security controls and the best practices within Microsoft's IT. So most likely that is, if not overkill, then at least it's useful or good enough for your organization as well. But really, the AzSK is really about this administrative or this platform level of access control of security configurations. You should also complement this with actual web layer or application layer scans and best practices as well. Follow maybe OWASP top 10 to evaluate your environment. Do pen testing, all of those practices. This is just the Azure infrastructure or Azure environment part of this overall security. And have a look at these different threat modeling tools that help you prioritize these confidentiality, integrity, and availability. Microsoft has their own tool called Triad. There's actually even a nice cardboard game that you can use to kind of, if you draw out your application's architecture, you can just play those cards and you get the point if there's a vulnerability related to authorization and so forth. It's not maybe something that you will spend your weekends with, but it's definitely something that helps you perform the threat modeling in a little bit more engaging way in your teams. And yeah, these are Microsoft's own best practices, so analyze them and also check, do they make sense? This is not a kind of free pass for your teams and yourself to say, whatever there is failing, it's not for us, not at all. But there are some services that maybe require extra costs, extra licenses, and some of those that really, from Microsoft's point of view, they focus a lot on availability. For example, not all of your applications need to be geo-distributed, for example.